Today we're going to review subatomic particles and talk about each of their properties, and then we're going to go into how to figure out how many of each of those particles are in a given atom, and touch briefly on what an isotope is and how you write the symbol for a particular isotope. We've already discussed what the subatomic particles are, the proton, neutron, and electron. Today I'm going to tell you what the symbols are, the charges, the mass, and where they're located in the atom, which should be a little bit of a review. So first let's start with the proton. The symbol for the proton is a lowercase p or a p plus. And the plus is there because the proton has a +1 charge. And you should remember that from the last video we watched about the models of the atom. The mass of a proton in atomic mass units is 1.007. So pretty darn close to 1. And as you should remember, it's located in the nucleus. The neutron is usually represented by a lowercase n or an n with a 0. And that 0 is there because the neutron has no charge. It is neutral. And so that can be how you can remember that. And the mass of a neutron is very close to that of a proton. It's 1.008 atomic mass units. And it's also located in the nucleus. And then the last subatomic particle is the electron. The symbol for the electron is an E with a little minus, and that's the symbol I'll use most often. That one has a -1 charge. Okay, and the mass of the electron is 0.00055 atomic mass units. So very, 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 very small. In fact, we usually assume that the electron has no mass relative to everything else that's in the atom. And we know that the electrons move around the nucleus. Okay, so those are the subatomic particles. Now I'm going to show you how to use the periodic table to figure out the number of each of the subatomic particles that are in each atom. So we're going to start with just a table like this, and each row represents one specific atom, and we're going to include the symbol, the atomic number, the mass number, and the number of protons, neutrons, and electrons in that particular element. So in the first one, we have to find some clue that tells us which atom we're talking about, and in this case, that would be the atomic symbol, which is C. So if we look at our periodic table and find carbon, which is right here, the number up in the left-hand corner is always the atomic number, and the atomic number is equal to the number of protons. So if our atomic number is 6, then we know that means the number of protons must be 6, and we can also write in the name of the element. So we know that C is carbon, and since it's a neutral atom, the number of electrons and the number of protons must be the same. And we know this is neutral because there's nothing beside the C in the symbol. The number of electrons has to equal the number of protons, so that should be 6 also. And then we can tell the number of neutrons because if you remember from our previous slide, the protons are each 1. Right? And the neutrons are each 1, and the electrons are pretty close to 0. So if we add up the protons and the neutrons, that will give us the mass number. So if our mass equals 12, that means that that has to be equal to 6 plus the number of neutrons. And I hope we can all do that algebra in our head, which means that the number of neutrons would be 6. Okay, so now we can go through the next one a little bit faster because we know what we're doing. So we are now looking at nitrogen, and nitrogen is here on the periodic table. Okay, so we know that the atomic number is 7. We know that the symbol is N. If the atomic number is 7, we know that the number of protons is also 7. Right, and there's nothing here to suggest that this is anything besides neutral, which means the protons should equal the electrons, so there should be 7 electrons as well. And it tells us here that the number of neutrons is 8. That means that the mass number should be the number of protons, which is 7, plus the number of neutrons, which is 8, so our mass number should be 15. All right, I'm going to do one more, and then I'll let you do the last one, and I'll put an answer so that you can check yourself. So the next one, we don't have a symbol or an element name, and we don't have the atomic number. What we do have are the mass number and the number of protons. Now, the number of protons, remember, is equal to the atomic number. So if our number of protons is 9, that means we're looking at fluorine, which is number 9 on the periodic table. Okay, so you can go ahead and fill in the name, it's fluorine. The symbol would be F. The atomic number is going to be 9. We already are told that the mass number is 9, and we know the number of 19, and the number of protons is 9. There's nothing to suggest this isn't neutral, so the protons and electrons should be the same, so that should also be 9. And the number of neutrons is going to be, the mass number is going to be equal to protons plus the neutrons, so the neutrons is going to have to be the mass number minus the number of protons, so that's going to be 19 minus 9, which would be 10. So continue with the last one and pause the video, fill that one in, and then come back and we will go over the answers. So these are what you should have gotten for the answers for the last one. If you didn't, make yourself a note and either come see me during ACT in the morning or make a note to ask me during class. I've mentioned isotopes before, but just so we have a clear definition, an isotope, or two isotopes, are atoms that are the same element, meaning they have the same atomic number, same number of protons, but have a different number of neutrons, and therefore have a different mass number. Because elements can exist in different isotopes, we need to have a symbol that clarifies which isotope we might be referring to. So magnesium, for example, has 3 different isotopes, and if we just use the symbol Mg, you wouldn't necessarily know which isotope we're talking about. And so I'm just going to go through what the different parts of the symbol mean. So obviously the Mg is what we've already used. That's the chemical symbol from the periodic table. The 12 down here in the corner is always the atomic number, or the number of protons. So the 12 is that little number on the periodic table that's on your periodic table, is up in the left-hand corner. But on the symbol, it needs to be written on the bottom left. Okay, and then the number up here, the 24, that represents the mass number, which would be the protons plus the neutrons. So if you do the top number minus the bottom number, that tells you how many neutrons are in that particular isotope of that compound, or that element. So now let's practice writing the symbols for the other isotopes of magnesium. So the question is, magnesium has isotopes with mass numbers of 24, 25, and 26. Write the symbol for each isotope and state the number of protons, neutrons, and electrons in each. Okay, so the first one, the symbol is already written for us above, but it would be the 24, because that's the mass number, and then the Mg. And then magnesium always has 12 protons. That's always its atomic number. Okay, for the one that has 25, the only difference would be that we put the 25 in that top corner, but the Mg and the 12 stay the same, and so the 26, again, the same pattern, just like that. Okay, so each of these, for the number of protons, is going to be 12, right? The number of electrons is also going to be 12, because these are all neutral. Isotopes are neutral. Okay, and then the number of neutrons is the thing that's going to change. Okay, so in each case, we need to do the top number minus the bottom number. So 24 minus 12 is 12. 25 minus 12 would be 13. And 26 minus 12 is 14. Now, you may have noticed that if you look at your periodic table, there is a different number for the mass than any of the numbers we just wrote down for the mass number of magnesium. So when you look at the periodic table, the mass of magnesium is not 24 or 25 or 26, it's 24.305. And that is actually the average of all of the masses of magnesium atoms if you sort of threw them all together and added them all up and divided by how many you had. And so that is the concept we're going to talk about next, the atomic mass. The atomic mass is actually a weighted average of all of the masses of the isotopes of that particular element. So we're going to do an example that doesn't use atoms just yet, just to help you wrap your head around what a weighted average is. So let's say that we have 10 bowling balls. 5 of them weigh 8 pounds, and the other 5 weigh 14 pounds. So how would we figure out what the average mass of the bowling balls is? So there's sort of two ways to approach this sort of problem. The first is we could add up the weights of all the bowling balls and then divide by the total number of balls. So that would be 8 plus 8 plus 8 plus 8 plus 8, that's 5 eighths, plus 5 14s, and then take that sum and divide it by 10. So then our average comes out to be 11 pounds. And we could also have done this by averaging 8 and 14, since we have an equal number of both size balls. And so if you average 8 and 14, you get 11. Now let's say that we have actually more balls that weigh 14 pounds than just 5. So we still have 5 balls that weigh 8 pounds, but now we have 20 that weigh 14 pounds. How is that going to change our average? So qualitatively, thinking about this, you know that if you add in a bunch more heavy balls, your average is going to have to go up, right? So now we know that our average is going to have to be larger than 11 pounds because more of our bowling balls weigh the heavier 14 pounds. So we could do this the same way that we just did, doing 8 plus 8 plus 8 plus 8 and so on. Or we could simplify it a little bit and use some multiplication. So we can do 5 times 8 plus 20 times 14, and then divide that sum by 25, which is the total number of balls that we have. So now, as we predicted, our average went up. So now instead of the average being 11 pounds, it's now 12.8, which is much closer to 14 than the average we got the first time. So now we're going to expand this concept into how we would figure out the atomic mass of different elements. In order to calculate the atomic mass for a given element, we need to know what different isotopes there are and how much they weigh, and we also need to know how much of each of that isotope is present in a given sample of that element. So if we go back to magnesium, the example we've been using, this problem gives us the percent abundance for each isotope of magnesium. And just as a side note, I wanted to mention that in addition to the way we wrote the isotopes a couple of slides ago, you can also write the isotopes like this. Okay, so instead of the 24 up in the upper left-hand corner, you can write the symbol Mg and then a little hyphen and the mass number. Okay, so this tells us that 78.7% of magnesium is magnesium 24, 10.13% is magnesium 25, and 11.17% is magnesium 26. So before we do any calculations, you can tell that most of the magnesium is magnesium 24. And consistent with that, if you look at what the average atomic mass is on the periodic table, it's very close to 24. So we know that the calculation that we're going to do should give us a number close to 24, and that it should be a little bit bigger than 24 because the other two isotopes are both larger than 24. The process we're going to use for calculating the atomic mass is very similar to what we just used on the previous slide to calculate the average mass of the bowling balls. So now instead of using the number times the mass, we're going to use the percentage because in order to get these percentages, they looked at a sample of thousands and thousands and thousands of magnesium atoms, and it's just not feasible for us to add up each individual atom and then divide by the total number. So remember that 78% would be 0.78 when we express it as a number. So we're going to do 0.787 times 24 plus 0.1013 times 25 plus 0.1117 times 26. And when we add all this together, multiply and add, we get 24.32, which is very close to the 24.305 that's on the periodic table. So that's it for today. That's your summary of subatomic particles, atomic mass, and isotopes.